In this screencast, we'll review just about all of the gas laws such as they are. We'll summarize them. We'll ask ourselves, what is Boyle's law about? The little ditty that you learned in the previous screencast should help. What is Charles's law about? Gay-Lussac's law, Avogadro's principle, sometimes known as Avogadro's law, Graham's law, the combined gas law, the ideal gas law. What is STP and when does it matter? What units are used for pressure, an unusual unit of measure that not everybody's familiar with? This is Screencast 10.3. Well, here they are, all sorts of different gas formulas and laws. This isn't the normal thing where we go through one at a time. Let's just take a look at each one of them. Boyle's law, as pressure goes up, volume goes down. Charles' law, as temperature goes up, volume goes up. Gay-Lussac's law, as temperature goes up, the pressure goes up for a non-expandable system. 22.4 liters of any gas or mixture thereof is a mole, that many particles, 6 times 10 to the 23rd, at 0 degrees Celsius and 1 atmosphere. If you can combine these laws, you come up with the P1V1 over T1 equals P2V2 over T2. And that's known as the combined gas law, when a few things can be changing at once. Ideal gas law, PV equals nRT. The pressure of a system times the volume of a system that contains gases is equal to the number of moles times a constant, which happens to be 0.0821 liter atmosphere over mole Kelvin times the temperature. For all of these, it's very important to note, you must use Kelvin for temperature. You'll notice that that is written there throughout. Graham's law. The rate of effusion of gases is inversely proportional to the square root of their molar masses. Whoa! Simply means that little gases go faster, but not that much faster. M are their molar masses, R are their rates, means their rates. Lots of units for pressure. We use PSI for tires, things like that. Millimeters of mercury for like air pressure. Kilopascals is a European one that you see a lot. And an atmosphere is equal to the pressure at sea level. Get to know all those. Here's how they all relate right there. Temperature. Lots of units are used. Fahrenheit, Kelvin, Celsius. For the gases, only use Kelvin. Can't go below 0, so it's good for math. Standard temperature and pressure matters when you're dealing with things like the Avogadro's principle. And that takes place at 0 degrees Celsius and 1 atmosphere. You're familiar with most of these units for volume, I'm sure. There's the ideal gas law constant, which shows up right there. N, it also shows up right there, number of moles. Capital M means the molar mass, for example, 18 for water. This is Screencast 10.3.